is said to be linear if the highest power of variable present in that equation is 1. So for example, we have x equals to a plus bx, that y equals to a plus bx, y is known as independent variable and a plus bx is known as, that y belongs to dependent variable and a plus bx is equal to independent variable, and where a and b are constant. I repeat, y equals to a plus bx. Suppose this is the equations. In that case, y is known as dependent variable and a plus bx is known as independent variable, and where a and b are constant. Moving to next part. The next one is the linear programming. These are the point belong to the definition. So it is an optimization.
So can you please show the previous slide once again?
You can write, or better you write this one. Short questionnaire came in case of 2 marks, specially reference to your examinations.
So that is A semicolon B.
अरे A comma B वो semicolon हो गया.
अच्छा जी, okay.
A and B है ना?
Yes sir.
Okay. So where y equals to a dependent variable and a plus bx is independent variable.
Okay sir.
And a, b are constant. Moving to next part. In case of linear programming, it is an optimization method applicable for solution of optimization problem where objective function constant are linear, that is known as extending along a straight or nearly straight line. Moving to the next part, the optimization problem may involve finding the maximum profit and minimum cost or minimum uses of resources. So in most cases, especially reference to industries, whenever they are go for maximize profit by using linear programming problem, they also kept about minimum of cost or minimum uses of different resources. Moving to the next part, it was first applied during 1930 by some economists, mainly in case of solving resource allocation problem. So what do you mean by resources? Anyone? What do you mean by resources? Pritisna Jana, what do you mean by resources?
Yes, sir.
What do you mean by resources?
Sir, the main products that are used for making the goods and services.
Okay. Ritika Mandi, what do you mean by resources?
So means the available products that are used for any purpose.
Company का कौन सा resources होता है? What are the different resources of companies?
So like stock resources. So like stock.
Raw materials.
Raw materials.
Okay.
So manpower.
Okay.
Employees. Yes, sir.
Okay. Anything else?
Money, sir.
Sir means
What?
Yep, you can.
Rakesh Mana, what do you tell?
Sir, supply of money.
Supply money. Okay. So basically the resources are man, machine, material. Clear? These are the resources. Man, machine, materials. These are the resources of any kind of companies. Clear? So this linear programming is especially applied in case of resource allocation problems. That means whenever you assign 20 number of people for a particular workstations, तो मैं कंपनी के प्रोडक्शन डिपार्टमेंट में 20 लोगों को भेज दो. That means you are assigned 20 number of people to that particular production unit. Clear? That is known as resource allocations, and in that resource allocation, linear programming is applied. And during 1975, that is L.V. Kastrovich from Soviet Union and T.C. Kopman from US jointly win the Nobel Prize for the application of linear programming to the economic problem of resource allocations. As I told, the resource allocation especially refers to your man, machine, materials. So as you know, if you take the case study of any kind of operation related company or any type of manufacturing company, most of the peoples are mobilized from one place to other place. That means if you see in your day-to-day life, in case of construction of bridges, so those companies who take the authority, they can mobilize the human resource from one place to another place. Even if they mobilize the machine from one place to other place. So these things can be easily, this type of problem can be easily done by the help of linear programming problems. Moving to the next part. So these are the characteristics of linear programming problem. The first one is objective function, is minimize the type. The next is all constraints are equality type, and all decision variable are non-negatives. I repeat, the objective function is maximize. That is, for example, maximize the profit. This is the objective function of any kind of industry. That is why industry are called profit-making organization or profit-maximize organizations. The next is all constraints are equality. That means man, machine, material are made, or these constraints are made in case of equalities. And in case of decision variable, so whenever in case of decision is concerned, most of the cases the top management is provide the decision, and these are non-negatives. The decision are always positives. Clear? The next one is, this is the typical objective functions. Just note down these ones. I will explain all the things. If you finish, just drop a text on chat box. Try to note down, clear. In physical mode, I will check you both your assignment as well as your note, clear. Day by day. So we have covered around 80 number of classes, clear. So we will meet on 22 February onwards on physical mode. So during the fast interaction, I will check your note as well as your assignment. So it is my personal advice to all of you that keep writing whatever we have discussed in the previous class and in today's class. Rajesh Patra.
Yes, sir.
Have you finished?
Yes.
Okay. Rasmi Parveen.
Yes, sir.
Okay. Let's discuss. Suppose in case of linear programming model or linear programming problem, that is max stand for maximization and the objective function is given 2x plus 5y. And then next part is that is the subject to, these are the constant, equation 1, and you can also call this is the first constant, and the second one is the second constant. Clear? The subject to x plus 2y less than equals to 16. So this is greater less than equal to 16. The next part is that is 5x plus 3y less than equals to 45. And the next part is that non-negative constant is given xy that is greater than equal to 0. That is non-negative constant, and where x and y stand for decision variable. So if you combine all the things, it should be formed as a linear programming models.
So is it an example or it is the exact figure that is the
This
formula?
type of question will appear. If
Okay.
you see this LP model,
Okay.
this type of questions will be
Yes, sir.
provided in your semester examinations. You have to find the feasible solution and find the optimal solutions
Yes, sir.
in case of related to problem. Clear? Before starting, if you know about the different aspect of this linear programming models, the first, the max or maximization of 2x plus 5y that belong to objective functions. The next part, subject to x plus 2y and 5x plus 3y, these two equations belong to constant. And the last one, that is non-negative constant. So if you combine starting from the objective function, constant and non-negative constant, it form a linear programming model. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
So I think all of you finish this one. Let's move to the next part. So in case of linear programming model, it is a mathematical model that finds the best solution with respect to some evaluation criteria. First one is your facility locations, vehicle routing and scheduling, machine and job scheduling, product mix and inventory management problems are formulated as constant optimization model as linear programming model. So these are the key areas as far as concerned with your company or any kind of industries. For example, in case of facility location, the facility means warehouse location or distribution center location. So as you know, in case of your operation related company, the Flipkart will take a full campus drive in your institute onwards 18 and 19. So in that they are directly focused on facility locations. The next is most of the dairy industries like your Umfed or your milk mo, they go for vehicle routings and schedulings, starting from morning hour or starting from evening hour. So they are employed the vehicle in case of collection of raw milk during morning hour, and in case of distribution of pasteurized milk in case of evening hour. So just imagine there are around 5,000 number of distribution outlet as far as concerned with Umfed dairy industries. So they are directly tie up with your Umfed industries. So just imagine how much demand will be placed by the number of outlet, and that demand will be easily fulfilled by from the side of your UMPET diary also. The next part is your machine and job scheduling. In case of machine and job scheduling, whenever the demand is on peak side, or whenever the customer demand is uncertain, in that case you have to go for arrange your machines as well as your job scheduling, especially reference to production or manufacturing. Then next part is product mix and inventory management. These are the different key factors or key area you can implement the linear programming models. Next part is your decision variable. In case of decision variable, it means physical quantity controlled by the decision makers. And decision variable takes any of the set of possible values. For example, the decision variable xm can represent number of kg of product that product m that a company will produce during some month. That is the concept of decision variable, and it should be taken by the higher authority or top level of management. Moving to the next part, the next and most important part of linear programming model, the first one is objective function. So in case of objective function, it defines the criterion for evaluating the solution. That means you have to find the optimal solution in case of maximization of profit. For example, the objective function may measure the profit or cost that occur a function of the amount of various product produced. So there is a company who can produce the particular product, and by the help of objective function, you have to identify the profit maximization with respect to minimization of cost. That is the things. The next part is the objective function also specify a direction of optimization, either maximize or minimize. In most cases, profit is maximized and cost of raw material and cost of other resources should be minimized. That is the concept of industries for maximize profit. Moving to the next part, the next part is constant. So in case of constant, the constant are set of functional equalities or inequalities that represent physical, economic, technological, legal, ethical, or restriction on what the numerical value can be assigned to the decision variables. I repeat, the constant are the set of functional equalities or inequalities. For example, physical, then economics, technological, legal, ethical, and other restrictions on what the numerical value can be assigned to the decision variables. In case of linear inequalities or equation or restriction or the variable of linear programming problem are called as a constant. In constant optimization model, the value of decision variable that maximize or minimize the objective function and setting all constants. So here in case of linear programming, you must concentrate on different constant. The function of constant is inequalities and that or equalities, and that should be directly convert the optimization model the value of decision variables. Last point, the objective function for several variables subject to condition that the variable are non-negative and satisfy the set of linear inequality called linear constant. Moving to the next part, the next one is method of solving linear programming. The first one is graphical method. The next one is basic feasible solution method. The third one is simplex method. Fourth one is revised simplex method. And the last one is duality or dual simplex method. So in
The
your course,
LPP means
I'm not getting your voice.
L double P is written.
Okay, your
The
voice is very
method
weak.
solving LPP.
These are the method for solving linear programming.
Double P means
linear programming program.
Okay, you are telling about LPP, na? Linear
yes, sir.
programming problem. LPP
Okay.
stands for linear programming problem.
Okay, sir.
So here the first method is your graphical method. The second one is basic feasible solution method. The third one is simplex method. The fourth one is revised simplex method. And the last one is dual simplex method. So in your course, only two methods are included. The first one is graphical method and the second one is simplex methods. Clear? So here, just note down these two methods. So we will discuss first one in case of graphical methods. So in case of graphical method, it involves indicating the constant on graph paper and determine the feasible regions. I repeat, graphical method involves indicating the constant on the graph and determine the feasible regions. So then the question is arise, what do you mean by feasible region? In case of feasible region, the common region determined by all the constant include x and y, that is less than equals to 0 of a linear programming problem is called feasible region for the particular problem. The next is feasible solution. The point within on the boundary region represent feasible solution of the constant. So here the typical example. For example, following is a linear programming problem. The problem statement is maximize z equals to 4x plus 3y. This is the objective function, and the constant r that is subject to x plus y less than equals to 5, then x plus 2y that is less than equals to 8, and xy that is greater than equal to 0. Find the optimal solutions. Just note down. Okay. Is it finished? Move to the next one. So first you have to draw the graph. So here I draw for your easy understand of this particular concept, especially reference to graphical method for solving linear programming problem. So here I just read the first one, that z equals to 4x plus 3y and x plus y that is less than equals to 5, x plus 2y that is less than equal to 8. Again, in case of non-negative constant xy that is greater than equals to 0. Find the optimal solution. So here I draw x-axis and y-axis. Clear? If you think about x-axis, suppose x is 0. What is the value of y? Anyone? The first one, first subject, x plus y. If x is 0, what is the value of y?
5.
5.
Less than equal to 5.
No. In that case, it cannot be considered less than equal. That x plus y equals to 5. Suppose the equation is x plus y that equals to 5. If I provide the
Then y
data
is
x,
equal to 5.
y is equal to 5.
Yes, sir.
So just let's draw the graph. Just a minute. So y is equal to 5 here. Yes or no?
Yes, sir.
Yes, sir. Yes, sir.
And x is equal to
So 0.
0.
0 means this one, na? 0 to 5.
Yes, sir.
Straight
Yes, sir.
line. This is straight line. If you consider, suppose your y is equal to 0, x is equal to how much?
So 5.
5.
5. That means 5 should be here. Here. Better for your easy understanding, I just make a circle. Just a minute. Make a star mark. Okay, here. This one is your first equation, that is x is equal to 0. And in case of second one, I just put another star here. That is if x is equal to, sorry, y is equal to 0, and what is the value of x? X is equal to 5. Is it clear? Next one, if you go to next one, in case of your x is equal to 0, what is the value of next? If you go to next equation, x plus 2y equals to 8. So what is the value of, if I put x is equal to 0, what is the value of y?
4.
4.
4.
Just a minute. Y value is 4, so I put 4 here. Okay. And if the y value is that is how much? 0.
0.
What is the value of 8? If
8.
y is 0,
Eight.
x is how much?
8.
8.
8. Just a minute.
So in the same graph, we have to plot the 3 equations.
Initially you have to draw the graph, then after you proceed to calculate. That is
No,
the
no, sir. I'm
concept.
asking in the same graph, we have to plot the 3 equations. Maximize and subject equations.
Only 2 equations you can use. I will tell the step. Don't worry about that. Here.
Sir, x is equal to 0 to y is equal to 4 सेटा y रो value ना अपन x value 4 नहीं चाहिए.
Oh, sorry. This one is taken as for y. Okay. So just minimize this one. Is it clear? The next, suppose y is equal to 0. What is the value of x?
8.
0.
8.
8.
Clear? So this area, if you draw this one, and starting from 5 to 5, then 4 to 8. Okay. If I draw this one, just a minute. First one is 5 and 4. 5 and 5, sorry. 5 and 5.
5
This
and
one.
5.
And the next one is your, which one? 4 and 8. So this area, under this area, starting from 0 to 4 and 0 to 5, this area is known as your feasible region. Is it clear?
Yes, sir.
Okay. Then after you proceed to calculate the different values. For example, x is 0 here in this equation. X plus y. What is the value of y?
So 5.
5.
5.
Next one. If y is equal to 0, sorry, x is equal to, sorry, y is equal to 0, what is the value of x?
So 5.
5.
5. Next one. If x is equal to 0, what is the value of y?
4.
4.
4.
If y is equal to 0, what is the value of x?
8.
8.
8. Clear? So how many points you got? 0, 5,
Excuse me.
5, 0 in case
4
of
points.
equation 1. The
Sir?
next one in case of, yes.
Sir, how you have written that x is equal to 0, y is equal to 4? From which equation?
But if you simplify, x plus 2y equals to 8.
Yes,
If
sir.
I put 0 against
Yes, sir. Yes,
x,
yes, sir. Yes, sir.
try to concentrate on slide. Okay.
Yes,
So how many points you find? First point belong to equation 1, 0 and 5. And next one is 0 and 5 and 0. The next one is 0 and 4. The next one is 8 and 0. Clear? Is it clear?
Yes, sir.
Yes, sir.
So these points are directly already mentioned in this particular graph. Yes or no?
Yes, sir.
Yes, sir. Yes, sir.
Okay. So from here, you have to proceed for the different step of graphical method. What are the different steps? The step are first step is known as, just note down this one, formulate the linear programming problem. That is step number 1. So in this linear programming problem, first you concentrate on linear programming model that includes objective function, the first constant, the second constant, that non-negative constant or non-negative variables. The second step is each inequality in this construct written as equalities. That means by the help of this particular linear programming model, you can directly convert inequalities into equality. That is why I told in the previous slide, if you find any kind of inequality, that is x plus less than 5, that means x plus y equals to 5. That means that the inequality are converted into equalities. Is it clear? Then step number 3, plot the constant line considering them as equations. Then next step, identify the feasible solution region, locate your corner point of feasible regions. Just note down, there are other steps are there. Did it finish?
Yes, sir.
Yes, sir.
Okay. Move to the next step. I just again repeating this step. Formulate the linear programming problem. Whatever the linear programming model is given. Basically, in case of linear programming model, which include objective functions, constant, and non-negative variables or non-negative constants are there. Then convert each equality into constant written as equalities. Plot the constant in line considering them as a equation. The next is identify the feasible solution region. The next is locate corner point of feasible regions. Next step, just note down, calculate the value of objective functions on the corner point. The next is select the point where the objective function has optimal value. The next is objective function is also plotted on the same graph paper by taking some arbitrary value of z. The z stands for your objective function, that is maximization of that particular equation given in case of question. And the last one is if the optimal value occur at the corner point of the feasible region, it is enough to calculate the value of objective function of corner point of the feasible region and select one which gives optimal solution. So this is the whole steps of your graphical method. Starting from formulated the linear programming problem, each inequalities in constant written as equalities, plot the constant line considering them as equations, identify the feasible solutions region. The next is locate the corner point of feasible region, then calculate the value of objective function, then select where the objective function has optimal value. The next is objective function is also plotted in graph paper and go for arbitrary value of z, that is known as maximization of your objective function. And if the optimal value occurs at the corner point of the feasible regions, it is enough to calculate the value of objective function of the corner point of the feasible region and select one which gives optimal solutions. Is it clear to all? Have you
Yes,
finished?
sir.
Yes, sir.
Okay. Move to the next part. So this is a typical examples are given, that is max or maximum 2x plus 5y subject to x plus 2y less than equals to 16, and the next equation is given 5x plus 3y less than equals to 45, and here x and y are greater than equals to 0. Find the optimal solution. Try to solve this one. All of you finish the question part?
Yes, sir.
Yes, sir.
Yes,
Yes,
Okay.
sir.
sir.
If you face any kind of problem, you can directly go to this. I will show that particular step for your better understand of this particular concept. That is, here I write x plus 2y, that is the first constant equations. It is less than less than equals to your 16. So if I put 0 here, what is the value of 2y?
8.
8.
8.
8.
8.
Okay, the next is if I put y is equal to 0, what is the value of x?
16.
16.
1, 6, just a minute. Okay, next one. If I put, in case of second constant equation, 5x plus 3y equals to 45. What is the value of y?
15.
15.
15.
15. Next, if I put y is equal to 0, what is the value of x?
9.
9.
9. Okay. Just forget about for easy calculating this linear programming by help of graphical method. Because most of the people, or it is difficult to draw this particular graph. It is easy in case of Excel, but in case of your Microsoft PowerPoint, it is difficult to draw all the things. Clear? For easy understanding of this particular concept, I will made some feasible steps for from my side. The first step is you have to convert the inequality into equality. That means make a particular tables. In that table, you have to write the first equation: x plus 2y less than equals to 16. Then 5x plus 3y less than equals to 45. Then after you made 4 number of column for equation 1 and for equation 2. So in case of equation 1, if I put 0 against x, that means y equals to 8. Again, in case of y, I put 0, that x value is 16. Similarly, in case of 5x plus 3y equals to, the value of x is 0, then the value of y is equal to 15. Similarly, if the value of y is 0, then the value of x is equal to 9. Is it clear to all?
Yes,
Yes,
sir.
sir.
Can you
Yes, sir.
plot this on the graph?
Don't go for graph, as I
Yes, sir.
told. Okay, I have already written step number 1. Then move to the step number 2. Just a minute here. So here I have write two equations. That is x plus 2y is equal to 16. 5x plus 3y is equal to 45. Clear? So how much I multiply to get the value of x and y here in the first equation?
2. Sorry.
5.
3, sir.
So 5.
5.
Yes, 5. I multiply here 5. 5 multiplied. That means this one converted into how much? 5x. This one is known as how much? 10.
10y.
And the last one is?
80.
Okay. You can subtract and calculate the value of x and y. That means how much? If you go to next part, that is 7y equals to
5.
35.
35. 35.
Y is equal to 5. So put this value in equation 1, that is x plus 2y, just a minute, 2y equals to 16. Here I put the x value,
Sir, x equal to 6.
x is equal to 6. Okay, just a minute, I write here x plus, that is 2 into 5, 2 into 5, that equals to 16. And if you simplify this one, x is equal to how much? 6. Is it clear?
Yes,
Yes,
sir.
sir.
Yes, sir.
Move to next one. Step number 3. In case of step number 3, in case of question, the maximum or the objective function is given, that is maximization of 2x plus 5y, or I can write z equals to, z represent for maximization. So z equals to 2x plus 5y. And I have mentioned all the point that is drawn from the previous slide. That is 0, 8, then 16, 0, 0, 15, 9, 0. All the things should be written here. And another value, that is the first one I have write, that is 0, 0. The next one is 0, 8. The next one is 6, 5. And last one is 9, 0. Is it clear?
अरे जो 6-5 टा
6, 5.
6, 5 वैल्यू वहां से लिया, x and y से, this one.
5 टा x y 5 क्यों मिलता है?
Oh, sorry, this one is wrong written. X is 5 and this one is 6. Is it clear?
Yes sir.
X is 6, Y is 5, na sir?
Sir, X
Yes,
is
sir.
6, Y is 5.
X is 6, sir.
Y is equal to 5.
Sorry, you are confusing. Okay. Okay, if you calculate the first maximization, what is the value here?
0? 0.
0.
Next one,
40.
40. Next one,
37.
37. 37.
37. Next one.
18.
18.
So out of these 4 points, which have a higher side or higher value?
08.
08. 40. 40. 40.
Second one.
So this one is your optimal solution. Just a minute, I will do. This is your optimal solution. Is it clear to all?
Sir, 0, 0.
So 0, 0 from
0, 0
where?
is the origin.
Sir, and 0, 8?
0, 8 in the first case.
Yes, sir. So then 6, 5?
6, 5 we have calculated.
Okay, sir. So then 9, 0.
First
Last
case.
one. Yes, sir. Last case. Yes, sir.
Okay.
Yes, sir.
Sir, 16 0 point टा कहीं छाड़ देले corner नहीं बोली.
Because that is a good question. In case of x, y value, if you go to the
Yes, sir.
third equation, that is non-negative constant equations, there should be x and y value should be greater than or equal to 0. That is why we just eliminate the higher side, that is 16 and 15 also.
15. Yes, sir.
Is it clear?
Yes, sir.
I repeat, x and y value greater than or equal to 0. That is why we eliminate 15 and 16. So if you draw by the help of this point, if you draw, you can easily got the same feasible graph in case of your previous examples.
No sir, माने point उड़ा sir केमिन हो graph draw करला परे corner point उड़ा को ना.
हाँ, corner point बराबर. Better you can take the corner side points. Is it clear?
Yes, sir.
Yes, sir.
नहीं, कुछ लोगों को डाउट है. Yes.
सर
Yes.
सर आप जो बोले जो x ग्रेटर देन इक्वल टू 0 होगा तो 16 0 तो ग्रेटर देन इक्वल टू 0 है.
तो अगर 16 ग्रेटर देन इक्वल टू 0 होगा तो अगर 0 से 16 लोगे तो कितना हो जाएगा वैल्यू? That is beyond the graph.
Yes sir.
Okay. Similarly, in case of your x, in case of y, if you take this 0 and 16, it should be cross.
Cross, yes sir.
Cross your feasible regions. That is why only the lower ones, especially reference to the corner point.
Yes sir. Yes.
Okay. Don't confuse about those things. Clear? Moving to the next one. Try to solve this one. Here I just read that is objective function is given 12x plus 16y subject to 10x plus 2y that equals less than equals to 120, 8x plus 8y less than equals to 80, and xy that is greater than equals to 0. Find the optimal solution. Just note down. Is it finished?
Yes, sir.
Yes, sir.
Okay. Move to the next part. Just a minute. Is the PPT is visible?
Yes, sir.
Yes, sir. Yes, sir.
Okay, just a minute. So here, for your easy calculations, that is 10x plus 220y, that equals to 120. So what is the value of x here? If I put 0,
0.
what is the value of y?
60.
10 or minus 10?
60.
Sorry. 60.
Sir, 6.
6, sir.
Okay. So if the value of y is 0, what is the value of x?
Sir, 12.
12.
Here, similarly, what is the value of y here if the value of x is 0?
10.
10.
10.
Next one, if the value of y is 0 here, what is the value of x?
10.
10.
Is it clear?
Yes, sir.
Move to next part. So how much you multiply here?
Both side रे multiply हो दीटा जाको equation रे.
You can convert inequality
Sir,
into
2 and
equality.
5.
2 and 5.
Yes, sir.
2 कहाँ multiply करोगे? Yes, 2 and
Sir,
5.
10x
Yes,
plus
sir.
20y.
2 and 5.
2 and 5.
In past cases, you multiply equation 1, that is multiplied with 2, and here you can multiply 5. That is multiplied with 5. So what are the equations? That is 20x plus 20y. That equals to how much? So this is 40y. 40y, that equals to 420s. The next equation is, that is 40x plus your 40y,
Sir, 240 na?
So
Sir,
that is 240.
240.
sorry, 240. 240, and this is 40y, that equals to how much? 400.
400.
400.
So what is the value of x here?
Sir, x equal to 8, y equal to 2.
Yes,
Y
sir.
equals to 2. Clear?
Yes, sir.
So which value you have taken in case of calculation of, you tell me that particular origin. If you have pen and paper, you just draw these lines, and corner should be chosen. Which line or which point you should take to go for maximization of optimal solutions.
So
First,
06.
okay, first one is 06. Next,
82.
82.
82.
82.
82. Okay. Next,
10 0.
10 0.
10 0.
and 0. Okay. Anything else?
Sir, intersect point ଟାକୁ ନିଆ ହବନି?
No, intersect, you cannot take the intersect point. Under the intersect point, that area is known as visible regions. Suppose I will show that one. Is it visible?
Yes, sir.
Yes.
So this intersection area, under this intersection area is known as feasible region. So you have to directly take the corner point. This 1, 2, 3, 4. Is it clear? Yes or no?
Yes, sir.
Okay.
Yes, sir.
Thereafter you calculate these
Yes, sir.
values. That FR stand for feasible region. FR stand for feasible region. Okay. So here you calculate the values. What is the
0.
value of 0? Okay. Start
0.
from
0.
0.
0, then 30,
30,
26,
20,
6,
26. The last one is
200.
your voice is breaking, I think.
Sir, 200.
200,
No, sir. Sorry, sir. Sir, 20, 20.
20.
Sir, 20. Yes, sir.
So which is your optimal solution?
Sir, the 0 and 6.
0 and 6.
No, optimal solution you can write in case of objective functions. That is z is equal to 30. That is the optimal
30.
solution.
30.
Yes, sir.
Okay.
सर इंटरसेप्ट पॉइंट तो नेले ना गोटे सर x0 y0 दीटा पॉइंट आ गोटे ओरिजिन आ गोटे 4 नंबर तो सर इंटरसेप्ट पॉइंट ही नोजन ना आपण
If you take intersection point, it's okay. If you not take, we have already find the. If you do not take this point, you are already getting the values. For easy understanding, that's why I put it. Clear?
Sir, Z equal to 30 केमती हला?
Sir,
Sir,
30
Z
only
equal to
96
96.
होगा वो.
96.
चेंज हो
96, 128 and
96
96,
128
128,
120
120.
Yes, sir.
yes, sir. Yes, sir.
How
Yes,
much?
sir.
Z equals
Sir,
to
96.
96.
96.
96.
Yes, sir.
then 128.
Okay. The next one is
128.
128, sir.
128.
this is 128.
Yes,
Yes,
sir.
sir.
128.
128.
Okay. So this is not your the 8 and 2 is the your feasible region. This one. I'm not actually calculating. Whatever you told, I just mentioned here. Okay.
सर ऑफलाइन कंटिन्यू करवा छाड़ दियंदो बे
Okay. We will continue on blackboard. It is more convenient to express all the things. Here.
Sir, so why will not write the fourth one?
Fourth one is the intersection point. You can take, but the thing is that it is in case of intersection point. In that case, below the intersection point, it should not be taken. That is the concept.
So then in
But for
any
your
question
easier
will not take the last point.
that is the boundary layer or boundary region of this feasible region. That is why we cannot take this one.
So then we'll take only up to 3 points. 1, 2, and 3.
I'm not getting a voice.
So we will have to plot the 3 points only.
Only 3 points only you have to mention on that. But in case of graph, you have to mention those 4 points.
Yes, sir.
Okay. So that's all from my side. Okay, I just go for off the records. Here.